Okay, I'm back. This is Dr. Graves with the CSUN Geography Department and geographyplanet.org. This is part 2 of a video in which I show you how to take some data from and compare individual schools against the average exhibited by the group so that you may put them in context. So what we did in the first video was to go through how to manage the data to get it to a point in which some analyses could be done. We've already calculated the average or the mean and the standard deviation and calculated the percentile score for enrollment. So we're going to pick up now with the second part, and I'm going to put my cursor in cell E1 here, and what we're going to do is just calculate percentile for free lunch. So that's percentile FL. Perhaps I'll do this from the bottom instead of the top. It doesn't really matter how we do it. I'm going to press Control C on the very last cell in column D, which is the percentile of enrollment. And I'm going to simply paste it one cell over to the right. And I'm going to get an error message. And that's because the data doesn't, it can't figure things out. So I'm going to press F2, and this is just sort of a shortcut way of doing things. Rather than having the value here in cell C1284 at the bottom of this green column compare itself to what's going on in the pink column, that doesn't make any sense. So watch what I'm going to do. I'm going to move my cursor right there on the edge of that blue box. I'm going to press down the mouse and just slightly drag it over to the right. So now what's going on here is that the software is comparing the value in cell C1284 down here marked in red against the entire data set for all the schools, the 1,283 or so schools in terms of percent free lunch. I'm going to press enter, and we see that this school, though it is the largest school at 1,304 students, it's only at the 78th percentile in terms of percentage of students eligible for free and reduced lunch. I'm going to press Control C, which highlights that formula, and I'm going to press down Control and Shift together at the same time, and then press once the up arrow. And then I'm releasing the Control key and pressing the down arrow once. And what that does is allows me to just copy that formula all the way up, with the exception of cell E1. There are multiple ways of doing it, so do it how you feel comfortable. And now I'm just pressing enter to paste the formula in the entire column of data. So that's the percentile for free and reduced lunch. And maybe I should click on this green formatting box so that you can see that that goes with that. So column E is calculated from the values in column C. So that's percentile. The last thing that I'll do with that is sort the data by column C, A to Z, and we see that this school here, Grandview Elementary, has very few and extremely low percentage of students, less than just over 1% it looks like, that are eligible for free lunch. And that puts it at the 0 percentile. And then if we come up here, we see that these schools in this block of data here are all set at 100% of the students are eligible for free and reduced lunch. And if we were to line them up There's the percentile scores that each of them get. Percentile is useful, but what we're going to do is calculate a related variable or do a related analysis, and we're going to standardize the values in column B, which is pink, and C, which is the first of the green ones. And what that does is put each of those values on the bell curve so that you can see and evaluate whether these schools are truly unique. And generally what we look for, evidence that the school or a data point is about 2 standard deviations above or below the average, the statistical mean. And when they exceed that, then that is typically or generally an indication that the value is unusual. So let's go ahead and try that, and hopefully you'll see what I mean. Let's start again with enrollment, and I'm going to put stnd enroll up here at the top of in cell F1, and then I'm going to type this formula, standardize, right? So I could either do that, or I could go to the Formulas tab, select More Functions, Statistical, and scroll down until I see Standardized, which is right there. Standardize. So the X that they're asking for is the value associated with a specific school. And in this case, it's the enrollment associated with Grandview Elementary, which is in cell B2. And now we want to, it's asking for the mean and the standard deviation. In this case, we calculated those in a previous video, so we have to go and find those values. And I'm going to scroll down, which is sort of the slow way of doing it, and find the mean. In this case, it's the average. Oh, shoot. That I should have tabbed first. So the mean is that number. My X is B2. Once again, I have to press F4 in order to freeze that value, to keep it from moving as I copy the formula to the rest of the row. And then the standard deviation, I need to tab or click in the standard deviation box, is right there. And once again, F4, or manually place a $sign in front of the B and in front of the 1287. So once I have that, I can press OK. It returns us to cell F2 and tells us that this enrollment figure is or 0.63 standard deviations above the average. So I'm going to press Control Copy and do this little trick here where I double click in the lower right hand corner, and that gives me the standardized score, or the Z-score, for all of the data that is in column B. And once again, maybe I should just click on that and make it pink so we can tell that that column of data is associated with the enrollment data. So let's go ahead and sort the column or all of the data by enrollment once again. So sort A to Z, and we see that there are some schools that are unusually large and some schools that are unusually small. So everything generally above 1.95, so these schools here, put them in slightly different, these schools here are all more than 1.95 standard deviations below the average enrollment, and so these are the ones that stand out as statistically unusual, really small schools. Not just regularly small, but generally, that 1.95 here, negative, indicates that these are really and truly unusually small schools. Not just average small, but really small. And these schools that are 1.95 and above are unusually large schools. So maybe we'll put those in blue. So these schools have unusually large things. They're not just above average, but they are truly unusual, is generally the way we think of that in terms of statistics. And so we see that that's, generally here above 96. These are all above the 96 percentile. Let's do this one more time, where we will do this for the percent eligible for free lunch. So we're going to put stand free lunch, and perhaps green again, and we can copy this formula over, but let's not do it at the top. I'm going to go down to the bottom and copy it over sort of once. I'm going to press F2, which puts me in edit mode. I'm going to click and drag this red box over and the purple box over. So now that the software is comparing 0.86 against the average and the standard deviation, which is derived from that column of data in C. And let's make that green. And we're just going to copy that formula. We see here that 86.3 is a 0.83 standard deviations above average. Copy that all the way up so it fills the entire row. And in the last instance, what we will do is once again sort the data A to Z, percent eligible for free lunch. Let me click in here, sort A to Z, and we find that these schools, once again, the ones that there are a lot of schools here that are 1.95 and above, it's about this many standard deviations below average in terms of schools that don't have very many students getting free lunch. And then what's interesting is that there's no schools that are 1.95 or above, 1.96 or above standard deviations for school lunch for students that are eligible, which tells us that the data is heavily skewed to one side. So I've highlighted the values in column C very quickly, and then what I'm going to do is insert a histogram of the data. And what that shows us very clearly is that the average, the middle of that bell curve, is to the right, and so we have a long left-hand tail, and so there are very few schools that are unusual that have a extremely high percentage, or having a high percentage of your students eligible to receive free lunch in Los Angeles is not unusual, but it is unusual to be down here far below the mean. And that concludes this video on standardization of data.